Hi guys, welcome to one of my favorite topics. This is called stoichiometry, and in this one, there's actually different types of stoichiometry. We're dealing with volume-to-volume ratios with gases, and we'll also be doing a lot more with this later on in the year. And of course, we're in Unit 3. You'll need your notes, which is your pen and paper, and you'll need your calculator with you. So for an overview, we're going to go through what chemical equations are. We're going to go through something called a mole map and example problems. So, chemical equations. We will discover this a little bit more, explore this a little bit more in Unit 4, but you've seen these before. It's when we have reactants on the left-hand side. So things that we put together, like say if we're going to put this in a beaker or a container, and we're going to have them have a chemical reaction to form the products. And we know we have chemical equations because we have the arrow. So anything to the left of the arrow are reactants. Anything to the right are going to be products. Make sure you have those. You remember what that is. We also want to look at the numbers in front of these formulas, or these compounds. So we'll notice here for NH3, there's a 2 in front. This is saying that there's 2 moles of NH3. Remember we said moles before were 6.022 times 10 to the 23rd particles? So there's 6.022 times 10 to the 23rd particles of NH3 in this reaction. We also have 3 moles of H2 over here. And in front of that N, that's actually just going to be a 1. It's an imaginary 1. We don't really put it in there, but we know it's there. It would not be 0 because then we wouldn't have any N2 at all. So it's 1 mole of N2. So all of these numbers are coefficients. And you've seen coefficients before in math class. They're kind of the same thing. So if I have like a 2 times x minus y, or I can have a 2 times a z, I know that that number in front represents how many of whatever I have next to it is. So I have 1 N2, 3 H2, so 3 moles of H2, and 2 moles of NH3. So let's get going through one of my favorite topics, the mole map. You're going to need some paper here. You might as well just start doing this on some scrap paper so that it can look a little bit better on your own notes. I'm going to give you all of it, all at once. I know we're only dealing with volume to volume right now, but in Unit 4 we're going to need all of it, so I might as well show you what the whole thing is here. So in the mole map, in the center of your paper, and again, might as well start with scrap paper here and make it look better later on. Color it, make it look fancy, all that sort of stuff. In this case I have circles, you can make them blocks. One block is a mole of A, so the mole of one substance. It could be like H2 from our example from before. And then to the right of that, a mole of B, that could be like NH3. And in between I'm going to do a mole ratio. That mole ratio, and you can write that for yourself, these are the coefficients from the chemical equation. Okay, so that's how you get a mole ratio. So, for example, before we said that we had 2 moles of NH3. So for every 2 moles of NH3 being produced, we would need 3 moles of H2 and 1 mole of N2. All right, got that? So from there, we're going to do liters of a gas at STP. So when we have this, it's kind of like 2 separate things. We're going to have like a border, essentially, right here. Anything to the left deals with one compound, anything to the right deals with another compound. So that's why we have 2 liters of a gas at STP both written here, because I want to show that to get from liters of a gas to a mole, I need to use the number 22.4 liters, just like we did in the last lesson. Then, if I want to go over to the different compound, I would use 22.4 liters in order to show how many liters of that gas I would have. So I'd use the conversion factors. And as another note, these can actually be double arrows. I don't know why I didn't make them double arrows. I guess it kind of looked pretty as it was. But these can also be double arrows too. Then from there, I have grams of a solid. This is something we'll deal with in Unit 4. I just want you to write this down so you have it in your notes. And the grams of a solid, we'll get that mass from the periodic table. So again, we know that on the left-hand side we have 1 compound, and on the right-hand side we have another compound. So I can go from grams of a solid to moles of A to moles of B, and say, for example, in B was a gas, so I could actually use liters of a gas there instead. So I can go in different directions at this. And I'm going to still do this as you guys are writing. So say, for example, substance A was a gas. I would go from liters of a gas to moles of that A, use those coefficients to get to B, and then I can use the mass from the periodic table to figure out what the grams of that solid would be if it were a solid. From there, we're going to do numbers of particles. We had 6.022 times 10 to the 23rd particles. And again, say, for example, I wanted to know if I had liters of a gas. So if I had 15 liters of H2, I can go from liters to moles using that number 22.4. So if I had 15 liters of H2 here. By the way, my cat just popped up, so she might be hanging out with us, or you might hear her meow for a little bit. From there, I could figure out what this might be NH3. So this was H2, that's NH3. I could use those coefficients to come over here, and then I can use 6.022 times 10 to the 23rd to get to the number of particles. So I could use this little route to get in my math, excuse me. And the last little thing we'll have is liters of a solution. So this is more of Unit 4 stuff again. So liters of a solution, if we mix in any of those ionic compounds into water, we can use big M. Make sure you make that a capital M, or MOL per L, so moles per liter. Alright, so we will make sure that we know how to use all of these, but for Unit 3, we're just going to focus in on this little section right here. Alright, so let's go through. Number 1, we have N2 plus 3H2 produces 2NH3. We want to know what volume of hydrogen. So whenever I do these, I underline and I label things. So I have X volume. Okay, so once volume, so I'm going to do liters. It doesn't say specifically which volume I want. So if it's in milliliters, I'd have to convert it one more time, but I know I can get to liters of a gas using, I can get to the amount of gas using liters. So what volume of hydrogen is necessary to react with 5.0 liters of nitrogen? So 5.0, if I had some more space here, I'd write 5.0 above it. So 5.0 liters of N2 to produce ammonia. That to produce ammonia, we don't need that quite yet. All right, I know I'm focusing on what volume of hydrogen, so I want to figure out how much hydrogen I need. So I'm going to start with the number that they give me, 5.0 liters of N2, and I'm going to set that over 1. From here, looking at your mole map, you're on the lower left-hand side where you have liters of a gas, and you want to get to moles of a gas. So you've got to get to moles first before you can get over to the other element, or the other compound. So I'm going to actually use my conversion factors. I know that 1 mole of N2 is equal to 22.4 liters of N2. And the reason I put the 22.4 on the bottom was so I can cancel out liters. Now I'm in the center. I have 1 mole of A, which in this case was N2. So I want to get to moles of H2. So I know, based upon my coefficient in my chemical equation, that there's 3 moles, let me do this in a different color, 3 moles of H2 for every 1 mole, because there's an imaginary 1 there, of N2. So I can get rid of moles of N2. Now I need to remember what I'm going to do, where I'm going to next. So I want volume of hydrogen. So now I'm going to go down. I'm going to go from moles of substance B, which was in this case hydrogen, to liters of substance B, using 22.4. So I have moles of H2 on the top. I don't want that. I want to get rid of it, so I'm going to put moles of H2 on the bottom. And I know from there I can use liters of H2. So I can cancel out moles of H2, and I know that that number was 22.4 liters per 1 mole of H2. So now I'm at a unit that I want, and I'm at a substance that I want. So I can go ahead and just do the math from now. To make it easier on yourself, and I like to just get rid of stuff I don't need. Look, there's a 22.4 here, and a 22.4 on the bottom. So those two will end up canceling. So before I even put anything into my calculator, I can get rid of stuff just to make it easier on myself. So really, all I would do is do 5.0 times 3. I don't need to do the times 1 because anything multiplied by 1 is itself. So it's 5.0 times 3. As a note for sig figs, anytime you have like the coefficients or like any of those numbers right there, and there, those are just kind of like placeholders for yourself. Don't worry about those in terms of sig figs. You want to stick with like kind of what you're given, or the 22.4 for sig figs. So no, I know here that's 2 sig figs, so my final answer will be in 2 sig figs. So 5 times 3 will give me 15. That's 15 liters of H2. So if I have, what this question means, if I have 5 liters of nitrogen, I need 15 liters of hydrogen in order to produce that many moles, or 2 moles of NH3. Right? So, the second question, what volume of ammonia is produced in the reaction in problem 1? So I'm going to erase some of those. I want to figure out how much, this is my unknown, how many liters of ammonia I'm going to produce. I can use, to start off with, the 5 liters of N2 or the 15 liters of H2, whichever one you prefer. I'm just going to do the 5 liters of H2. That's fine. Or excuse me, 5 liters of N2. I apologize. 5 liters of N2 over 1. And then from there, I'm going to get to, from liters of this gas to moles of the gas. That's the only place I can get to next. So I can get 1 mole of N2 here over 22.4 liters of N2. I did that because I want to get rid of liters of N2. Now I'm in moles of N2. I want moles of ammonia. Excuse me, I want liters of ammonia at the end, but I need to get to moles of ammonia first. So I'm going to use those coefficients in the chemical equation. So in front of that ammonia, I have 2 moles of NH3, and I have 1 mole of N2, because there's an imaginary 1 in front of there. Get rid of the moles of N2. And then from there, I'm in moles of NH3. I want to get to liters of NH3, and I'm just using that map to help me. So I know that I want moles of NH3 here, because I want to get rid of it. That's supposed to be a 3. And I want liters of NH3 here. Knowing from my conversion factors, 1 mole of any gas is equal to 22.4 liters of a gas. So I can cancel out moles of NH3. I'm left in a unit that I want, because I wanted volume, and I'm left with a chemical or compound that I want, which is NH3. So let's make this easier for ourselves. Let's get rid of any numbers we don't need, so that way when I put this into my calculator, it's just easier for me. So just kind of scanning through and looking at whatever's on the top, compare it to whatever's on the bottom. So I know I have 22.4 here and here. I can get rid of them, I can cancel them, because the ones on the top, ones on the bottom, they will cancel out in my calculator anyway. So in my calculator, I'll just do, actually you don't even need a calculator, 5 times 2. And I want to make sure I end up with 2 sig figs at the end. So 5 times 2 give us 10. And make sure that you're in the unit that you want, liters of NH3. Also, don't forget, since you did want 2 sig figs, make sure that decimal point is right there for you. So I know, looking at this work, it looks kind of crazy. The more you do it, the easier it is. How about that? So, stoichiometry involves the coefficients in the balanced chemical equation. And to convert between moles and liters of gas, you just need to use, or remember the number 22.4. We will practice this a lot. Don't worry, it'll actually end up becoming really easy, and it's really fun, because it's one of those things where you're like, I'm just doing some stoichiometry, and then you can kind of impress your family and friends. All right, I'll talk to you guys later. Take care. Bye.